the definition of composition of two functions. So this is lesson 5, part 2, and we're going to talk about compositions of functions. So it's kind of like saying f of g of x. So again, if I'm looking at this picture right here, I see, maybe can we make it a little bigger? No, not really. Okay. So I see, hey, I've got f, it's like fog, okay, but it's an open circle. So that's like saying f of g of x, which is saying, hey, I want to take the function of the function g of x. And so I like this picture over here, as you can kind of see. Again, I have to take my domain of g and my domain of x, or my domain of f, and that's going to give me f of g. So I'm going to plug in x into g of x, and then whatever answer I got, I'm going to then plug into f of x and figure it out. So let's use an example. F of x equals x squared, and g of x equals x plus 1. So fog, right? F of g of x is going to equal, I'm going to start with my function of f on the side, or on the outside, and that's x squared, okay? So again, the whole thing is going to be x squared. I misspoke there. I'm actually going to start with my inside function, which is g of x. So my g of x is x plus 1. And then f of x, so let's highlight that. That's how we got that right here. And then my f of x is actually x squared. So I'm going to take everything that was inside g of x, and I'm going to plug it in where x is. So I'm going to end up squaring this. So again, that's how I got this part right here. So g of x is in the middle, and f of x is on the outside. So again, I could kind of write it like x plus 1 squared. That would be fine. Again, you could say that this is f of g of x. You could also multiply that out. X plus 1, x plus 1. Okay, you could multiply that. All right, so getting into a kind of a more concrete example, find f of g of x when f of x, so f of x equals the square root of x. X must be greater than or equal to 0. And g of x equals x subtract 1, but x has to be greater than or equal to 1. If possible, find f of g of 2 and f of g of 0. So f of g of 2 is first. So let's start with that one. So f of g of x. So I'm going to take g of x, which is x minus 1, and I'm going to plug that into everything that was f of x. And so f of x was the square root of x. So I'm going to take the square root of x minus 1. And again, because it's not x anymore, it's a 2, I'm going to replace all my x's with a 2. So let's see here. The square root of 2 minus 1 is 1. The square root of 1 is 1. So I was able to find the solution of, hey, I got the answer of 1. So as long as, and then I double check my domains, that works, right? So I could say that basically any number, the domain for this is that any number that's 1 or larger is going to work. Now, thinking about those domains, this is not possible because my domain for g of x says it must be bigger than 1. So f of g of 0 is not possible. It's 0 is not in the domain. So we would just say not defined, not involved, can't do it. All right, let's keep going. So given f of x, x plus 2, and g of x, 4 minus x squared. So let's write the functions down first. F of x equals x plus 2. G of x equals 4 minus x squared. Part A, find f of g of x. Part B, find g of f of x. And they wanted us to do that when x equals 0, 1, 2, and 3. All right, well, I'm going to start with part A. And again, I'm going to take my inside piece. So again, this is like saying f of g of x. I'm going to take what's inside, 4 minus x squared. And then every time in this function that I see an x, I'm going to plug that in. So in this case, all I have to do is add a 2 on the outside. So f of g, and I'm not going to solve it quite yet. I've got some like terms here. 4 plus 2 is 6. So I would just say 6 subtract x squared. We like to put the exponent first. You could write it like that as well. Totally okay. So you could go ahead and again, you could say, well, f of g of 0, f of g of 1, f of g of 2, and then f of g of 3. Again, just plugging this number in to your equation to get the answer. So if we did that, we would get 6, we would get 5, we would get 2, and we would get -3. Now, you could do that. I would recommend using your calculator. Negative x squared plus 6. Let's see here. When x is 0, y is 6. When x is 1, let's see here. When x is 1, y is 5. There we go. When x is 2, y is 2. When x is 3, y is 3, -3. And that's exactly what we got. So you absolutely can use your calculator to help you speed up. I would strongly recommend doing that. All right, so we gotta answer part B. We gotta answer part B. G of f of x. So again, that's like saying I'm gonna take my f of x function and then I'm gonna plug it into g. So f of x is x plus 2. So I'm gonna say equals x plus 2. And then every time I see in g of x, it's 4 minus x squared. So I'm going to say 4 subtract x plus 2 squared, because that was my function for g of x. So again, you'd have to side work, okay? So sidebar, x plus 2, x plus 2, x squared plus 2x plus 2x plus 4, x squared plus 4x plus 4, and I have this 4 on the outside. And I almost made a oopsie mistake because again, this gets sent into all three terms. So 4 minus x squared minus 4x minus 4. Like terms cancel out. G of f of x equals negative x squared subtract 4x. And again, I would use my calculator. Don't need this one anymore. Negative x squared minus 4x. I would say, okay, what is it when x is 0? Well, it sure looks like y is 0. Whoa. And then when x is 1, looks like y is negative 5. When x is 2, again, using your calculator as your friend is going to help you a lot. Could you do it by hand? Absolutely. And if you want to do it that way, you can do it that way as well. You would just plug in, you'd plug in 0 every time. You'd plug in 1, 0, 1, 2, 3, and you would solve it. Every time you see an x, you would plug in those numbers. I'm trying to see here. I think we're going to be, we should do these ones. Okay, identifying a composite function. So you might have to go in reverse order as well. So again, let's say that the composite function equals h of x equals 3x minus 5 to the third. I want you to come up with an f of x and a g of x so that we could find f of g of x. So if that's the case, well, f of x in this function would have to be x to the third. Looking at, again, thinking about it like this, x to the third. And then g of x would have to be my inside piece, which would be 3x minus 5. So again, I might ask you to work in reverse order. I'll give you the composite function, and you need to be able to work backwards. One more example of those, h of x equals 1 over x minus 2 squared. So again, I would say, I probably have, again, say it's g of f of x this time. No big deal. I would say that g of x would be 1 over x squared. If you remember your exponent rules, you could also say that it's that. They mean the same exact thing. And then I would say, well, if that's the case, then f of x has got to be x subtract